Okay, for the next part, we're going to try to find the points where the tangent is horizontal or vertical. So, we've done tangent lines being horizontal before, and actually even vertical we can kind of figure out with undefined slope. The problem is when you have it in terms of parametric curves, you kind of have to look at each individual component again independently. So the way I would sort of look at this is if you have a horizontal tangent line, it's going to look like this, right? But it's not as simple as just saying the slope is zero because, that would be Cartesian, representation. Slope is just zero. We have to think of it in terms of x specifically or y specifically. So if there is a tangent line, going this way, that means the x value is changing or has the potential to change here. It's the y value. There's no, there's no rise to this. It's simply just a run. So that means dy dt is going to end up being zero here, and dx dt is going to have some other value. Same kind of argument going with a vertical tangent. Our vertical value may be changing, but our horizontal value is not changing. So my dx dt is going to be zero here. So when you go to do these, you want to look for independently when is dy dt zero to make a horizontal tangent, and when is dx dt zero to make a vertical tangent. Note that they can't both be zero because then the particle would actually be at rest and wouldn't have a tangent line there. Okay, so find the points where the tangent is horizontal, vertical. Well, I've already got my derivatives from the first part, so let me just kind of cheat a little bit. I'm just going to recopy it. Dx dt was 2t, and dy dt was 3t squared minus 3. This is from the first video. If you didn't see how I got all that, just take a look at that one before you see this one. And so to get dx dt to be 0, of course, t is 0. And to get dy dt to be 0, I've got t squared minus 1, so t equals plus or minus 1. So at t equals 0, I'm going to have a vertical tangent, and at t equals plus or minus 1, I'm going to have a horizontal tangent. So it says, find the points where this happens. I kind of have to look back to the original function, and I'll write it up top here. Just sort of have to keep going back and forth with the papers. Y is t cubed minus 3t. So at t equals 0, the point is 0, 0. So that's where I'm going to have a vertical tangent. And I'm going to have a horizontal tangent when t is plus or minus 1. So at positive 1, oops, I shouldn't have put that there, although it actually is 1. I meant to just put at 1. It just so happens when t is 1, x is 1. When t is 1, this is 1 minus 3, which is negative 2. So that's at 1. And at negative 1, I actually get 1 comma negative 1 plus 3 is positive 2. So these are my horizontal tangents. Again, vertical tangent is going to happen when dx dt independently is 0, and horizontal tangents are going to be when dy dt is independently 0. Because again, if I look at dy dx, which is my dy dt over dx dt, and I want to actually figure out my slope being 0, only dy dt is going to be 0. Dx dt can't be 0 because then it would be undefined. If dx dt is 0, then and dy dt is something else, well then I have vertical tangent because my slope is infinity basically, or negative infinity. But both won't be 0 in order to get one of these tangents. Okay, so hopefully that helps with those kinds of problems. Obviously, if you need any extra help, be sure and let me know, and I will see you later.